David Hume's problem of induction has called into question a fallacy which all science is based, as brought up in the 18th century. It is the question, why does past experience give us any reason at all to think that future experiences will be a particular way, such as the laws of nature that appear to remain more or less constant? And more precisely, does inductive reasoning lead to knowledge, and what is the justification for it? Take the following example of ampliative induction. We'll call the following argument A. Premise 1, I have observed a sample of 100 apples. Premise 2, all the apples that were observed were green. Conclusion, it is probable all future apples observed will be green. So, by generalizing about green properties of a class of apples based on 100 observations, I am assuming a valid connection exists between the premises and conclusion. But it is this very assumption that Hume's problem concerns. I will demonstrate. We'll call the following argument B. Premise 1, patterns have held up in the past. Conclusion, thus, it is probable that patterns will hold up in the future. The problem of induction shows us that there is no such justified reason to think past experience with all green apples will even likely yield all green apples in the future. Arguments A and B use ampliative induction inference patterns to reason beyond the scope of the premises, from a limited sample of apples that have a particular property, to all apples that have a similar property. According to Hume, my argument is seriously lacking. I am not guaranteed that my conclusion will be true just because of a past experience. Not only this, but there is no reason to think that my prediction will be more successful than unsuccessful without assuming argument B true. To understand the magnitude of the problem, Hume points out three assumptions that typically entail inductive reasoning. First, past events will resemble future events. Second, all members of a particular class will resemble those of the past. Third, similar causes have similar effects. Are these assumptions true? Even if these are, there is no valid connection to understand it is so. In argument B, where is the valid connection between premise 1 and 2? We cannot infer 2 from 1 deductively either, because this would be assuming the very thing we are trying to prove. Moreover, we use induction to justify induction, which is to say that inductive reasoning works because it's always worked. This is what philosopher Wesley Salmon calls rule circularity, and has several major problems. By inductively reasoning induction, an astrologer could justify their method of using the stars to predict and acquire knowledge on the same grounds as the inductivist who is enjoying a string of luck that's about to expire. The same would apply to a counter-inductivist who would consequentially be as justified to conclude the opposite of the inductivist, maintaining patterns have held in the past, so they will not in the future. This is similar to the gambler's fallacy, that one's chances increase as one plays. So how do we get out of this mess? There are two proposed solutions we will cover. The first of which is the pragmatic approach. The pragmatic justification of induction takes a turn in an entirely different direction than typical proposals, for example, by the philosopher of science, Karl Popper. This approach doesn't look to actually understand the relationship of the past to the future. Instead, it is to say that if there are any reliable methods of prediction, induction is one of them. It says ampliative reasoning will work as well as any other method, if not better. Take argument B above and imagine a wager on whether the principle of uniformity of nature is going to be most likely true between the following two methods of prediction. Method 1, ampliative induction. This says we may choose to wager the principle of uniformity of nature as a possible state of the world or not. Or method 2, any other method of prediction against ampliative induction, let's say reading tea leaves, and we will also have to choose to wager the principle of uniformity of nature or not. What we find in assuming and wagering the principle of uniformity of nature as the most likely prediction, ampliative induction makes increasingly successful predictions, significantly more than reading tea leaves. So, why choose some other method of prediction? And why choose against the principle of uniformity of nature when the chances of winning the wager are so slim? We choose ampliative induction because it's reasonable to choose that which has the greatest chance of success in predicting the future. Doing otherwise is unreasonable. Thus, we have justification for why we choose induction. It appears this justification also overcomes the challenges of counter-induction. To infer the claim that patterns have held in the past, so they will not in the future, is clearly going to be unsuccessful in making predictions opposed to implicative induction. However, induction isn't fully explained yet. Despite its ability to predict success, all we know is that induction is a reasonable choice in light of other methods. We still do not understand the valid connection of inference from the past to the future. The pragmatic approach neglects trying to identify the core of the problem, nor does it explain the actual fundamental correlation. Nonetheless, it's the answer that will have to do. It has come closer than those before it. And it has effectively demonstrated why it is reasonable to choose it, but not why it continues to be rational to choose it. A second proposal tries accounting for the laws of nature themselves. If we quantify the laws of nature, and add them as auxiliary hypotheses and background theories to our experimental prediction, the principle of uniformity of nature would no longer be some sort of inductive wager but an antecedent condition accounted for, along with our other assumptions like temperature, air pressure, and so forth. This explanation is along similar lines as the pragmatic approach. However, it remains subject to the same objections, in that this does not explain the correlation of past to present. Other more philosophical considerations on the problem of induction directly concern the continuity of physical laws. This is the suggestion that there may be a metaphysical explanation for how things like natural laws originated, if at all, and why they remain relatively constant. For example, if what we call the laws of nature came into existence in the event of the Big Bang, the question remains as to what generalizations were imposing on the singularity when it exploded. One may point out that natural laws break down on the quantum level, but this does not answer the question why there are laws, rules, generalizations and behavior that exist to enforce limitations on matter, energy, and the like. Nevertheless, we can hope Hume would be satisfied with our answer. As it stands, Hume's problem of induction is still very much a problem yet to be solved.